It's Laurie from LlamaIndex here, and today I'm going to be walking you through our notebook that teaches you how to build your own deep research clone. We're going to be starting from no knowledge of LlamaIndex or workflows or deep research for that matter, and we're going to start with using the agent workflow, which is a high-level construct that allows you to quickly create agents and multi-agent systems. Then we're going to move on to workflows, which are the system that agent workflow is built on top of, and build our own custom workflow that will allow us to put together a deep research clone. So let's dive right into that. The first thing that you need to do is install LlamaIndex with pip install LlamaIndex. Then the next thing you'll want to do is you'll want to get an LLM. We support more than 400 different LLM models through 80 different LLM providers. So you have a lot of options. Today I'm going to be using OpenAI because it's simple and you can get a free API key for it. After pulling my API key out of the Colab, we will import the OpenAI adapter and instantiate our LLM with one line of code. You just say what model it is and what your API key is. If all you want to do is play with an LLM, you're done. You can just call llm.complete and ask it a question or ask it to complete some text, and it will do that for you. But we are going to be doing much more with this LLM today. One of the key features of agents is tool use. Agents are a way of programming where you give an LLM the ability to make autonomous decisions about how code should execute. And one of the things that they can do is they can use tools. They can use tools to get more information about the world, or they can use tools to take action. So in this case, I'm going to be creating a tool that allows my agent to search the web. This is cheating a little bit because modern OpenAI models have a built-in tool that allows them to search the web. But I wanted to give you a sample of what it's like to build a tool that can talk to any third-party API. So we're going to be using Tavily, which is a service specifically designed to allow LLMs to search the web. So we install Tavily's package. Tavily requires an API key as well. And now we create a function in Python. Agent tools in LlamaIndex are just Python functions. You can see us creating a function called search web here, which accepts the query parameter, which we've added a type annotation to say is type string. And we've also added a type annotation to say that it returns string. We've added doc strings here. That's this text in the triple quotes, which describes what this tool does. And then we're just calling the client, the Tavily client with our API key and returning the results as a string. The stuff to know about building a tool for LlamaIndex in Python is that all of this metadata is important. The name of the function, the type annotations for what things it accepts and what things it returns, and especially the doc string are used by the LLM to decide whether or not this tool is going to be useful and what this tool does. So when you're making your tools, you should pay a lot of attention to using descriptive names there. Now that we've got a tool, we can instantiate an agent and give the tool to the agent and tell it to do things. Like I said, we're going to be using Agent Workflow to start with this because Agent Workflow has a lot of built-in conveniences that make it easy to get up and running with an agent. So we'll bring in Agent Workflow from core Agent Workflow, and we're going to be using the method from tools or functions. So that takes an argument of an array of tools. In this case, it's just one, the search web function, but we could give it as many tools as we wanted. And we tell it what the LLM is, the OpenAI that we instantiated earlier, and then we give it a system prompt. We say that you are a helpful assistant that answers questions. If you don't know the answer, you can search the web for information. This is often key. LLMs will often try to answer questions by themselves. So a thing that you want to do is indicate to your agent in its system prompt that you expect it to use tools and what you expect it to use those tools to do. So now we can run our agent. An agent workflow always takes a user message as its parameter, and it can be run by just calling workflow.run on the agent. The response is a response object, but we can coerce it to a string. And we get that the current weather in San Francisco, or at least when I ran this notebook, was 17 degrees Celsius. By default, the agents created with Agent Workflow are stateless between runs. That means they don't remember previous times that you've run them. But it can be very useful to have an agent that does understand things that have happened before. So there's a mechanism to do that common to workflows and the agent workflow called context. To use it, we're going to bring in context from core workflow, and we're going to pass our workflow, our agent, to the context. This configures the context to work properly with that workflow. Then we call workflow.run again with the same user message, but just with a context object now. The first thing we're doing is we're just telling it that my name is Laurie. Nothing has changed since the last time. But now, if we run this workflow a third time and pass it the context again, this time we can ask it, what is my name? And it remembers from the context what my name is, that my name is Laurie. It is possible to maintain state over longer periods by taking the context and serializing it to disk and then unserializing it and passing it back in. When you are reading this notebook, you can click on this tutorial to find out more about how to do that. But right now, we're going to be talking about how you can access the context from within tools, because it's useful to be able to have not just your agent itself remember what happened in the context, but also have your tools be able to pull stuff out of the context and modify the context. So here we are creating a very simple agent workflow that sets a name. So I've created a tool called setName, and it takes context as a parameter. This is special framework magic, which is that if you tell a tool to accept context as its first parameter, then the framework will automatically pass the context in. And we've told it to also accept a name and to return a string. And it does something very simple. It gets the state out of the context, and it sets a variable within the state called name to whatever name has been passed in, and then it sends it back to the context. So now we instantiate an agent workflow from tools or functions again. We give it this set name function. We give it the LLM. We give it a system prompt saying, you are a helpful assistant that can set a name, which is a very simple agent. And we give it an initial state. This is new. So this is the initial value of the state variable, which we're going to say has a key called name that is currently unset. Then we create a stateful workflow context by passing in the stateful workflow to the context. And we run our stateful workflow. So we give it a user message of my name is Laurie, and we pass in a context, which is this time the stateful workflow context. Then we print the response, which you can see is nice to meet you, Laurie. And we can access the context directly. So we can call get state on the stateful workflow context and print it out. And you can see that the tool has correctly set my name into the context variable. One of the things about agents is that they can take a long time to run. So you don't usually just run an agent and wait for the response. One of the things that you're going to want to do is give your user a sense of what is going on under the hood of the agent, so that they get some kind of intermediate sense of what's going on before they get the final result, because an agent can take a minute or two to run if it's doing something complicated. So let's see how we do that using streaming output and events. Agent workflows return a stream of useful events about what is going on under the hood of the agent. Those include agent input, what has been given to the agent output, what it has output, and details of what tools it is calling and what results it got from those tools, as well as an event called an agent stream, which contains the streaming data that comes back from the LLM itself. In this instance, we're just going to look at the agent stream by itself. The way that you access the stream of events from an agent is you call run just like you do before, but instead of awaiting it, you just assign the output of that call to a handler. This gives you a handler that you can call stream events on. which will give you this stream of events. It will give you all of the events. You can see here in the commented out code all of the different events that you could be capturing. But in this case, we're just going to look for instances of the agent stream event, capture it, and print it out. So as you can see, that gives you the same output that the LLM gave us before, which is the current weather, except this time it's in Saskatoon. We can see a lot more detail about what's going on by uncommenting those lines of code and seeing everything else that happens. So you can see here what input was sent to the agent. You can see what agent was running. There's only one agent, so that's not very interesting this time. You can see the output. You can see it making a tool call. You can see what arguments it passed to the tool. You can see the tool output, and you can see the final response that it made. I think a thing that's interesting here is that the query that was sent to the tool is current weather in Saskatoon. That isn't quite what we asked. We asked, what is the weather in Saskatoon? When the LLM is deciding how to call a tool, it decides what arguments to send to that tool. So it's not just sending our query directly to the tool blindly, it is turning it into what it thinks is the right command. Another thing that you're going to want to do with your agents is get a human in the loop sometimes. Humans work very well with AI agents. Sometimes you'll want your agent to consult a human on what is the best course of action if it can't figure it out, or you might get it to check the agent's work and provide feedback, or if it's making a big decision like to send some money or to delete a file, it might ask for confirmation before it does that. This visualization that you're looking at here is a visualization of what an agent workflow looks like, or what is happening under the hood of our agent. There are a series of steps, that's the blue bubbles, and they are connected by events in green. So you can see that these events look familiar. They are the same events that we were outputting just now. These are the events that come out of the stream. And to get our human in a loop, we're going to get our tool to emit a specific kind of event, a new event that isn't received by one of these steps in the workflow. We'll output this new event, and then the workflow will wait until it receives a new event, a human response event, that tells it to resume and gives it a human response. So let's look at how that's done. We need to bring in these two events. They are a new kind of event, and they are special events. They take strings by default, but you can subclass them to take any kind of data that you want. And in this example, we're going to create a new tool called dangerous task. This is a dangerous task that requires human confirmation. And here you can see what it looks like to get a human in the loop. We're going to call wait for event on the context. And this is the event that it waits for. And this is the event that it sends out to wait for that event. In this case, we are sending out our input required event with a prefix and the username. Those are both optional. You can send out your input required event with anything. It just happens to be a convenient thing to set the prefix to what question should be asked to get the human input. And we're going to set our requirements, which is that the username on the returning event, the human response event, should also be Laurie. This is useful if you are handling multiple human events in parallel and you need to make sure that you are talking to the right one. You could set this to some kind of ID. What we're going to do once we get the response is we're going to do some simple string manipulation on it. And if it is yes, then we are going to say that the dangerous task completed successfully. And if it's not, then we will cancel the dangerous task. We're going to create our agent just like we did before from tools or functions. We give it the dangerous task tool, and we tell it that you are a helpful assistant that can perform dangerous tasks. Capturing this event and handling human input and output is the same as handling the output events that we were looking at earlier. So we're going to call workflow.run and get a handler. And this time we're going to look for instances of the input required event. The input required event, once we get an input required event, we will call Python's built-in input function, which will ask for keyboard input. And here we are using event.prefix to say what the prompt for that input should be, but we don't have to. We could have set that ourselves. We take the response and we call context on the handler and we call send event. with our human response event, which contains our response and the username that we were talking about earlier. So you can see what this looks like in practice. It asks us, are you sure you want to proceed? Because that was what the prefix was. And we type in yes, and then it says that the dangerous task has been completed successfully. So congratulations, you have created your first agent workflow agent. But agent workflows can do more than just be a single agent. You can create a multi-agent system with them. So let's look briefly at how we do that. To create a multi-agent system, first, we're going to have to create multiple agents, and we're going to decide what they do. In this case, we are going to have our multi-agent system write a blog post. So we're going to have a research agent that will search the web for information on a given topic. We will have a write agent that will write a report using the information found by the research agent. And then we will have a review agent that looks at that report and provides feedback. There are lots of ways that we could go about doing this, some very simple, some more elaborate. What we're going to do in this case is we're going to create 4 tools first. We're going to have a web search tool, which searches the web for information on a given topic. This is exactly the same as the web search tool that we were using earlier. We're going to have a record notes tool, which is going to take the results of the web searches and save them to the context for us. We're going to have a write report tool, which is going to take the report written by the LLM and write that to the context. And we're going to have a review report tool, which is, again, going to take the review written by the LLM and write that to the context so that we can access them as well. This is what those tools look like. You can see the search web tool calling Tavily as before. You can see the record notes tool. All it does is get the state and set research notes into the state. It can do lots of different research notes if this tool gets called multiple times. The write reports tool sets the report content in the state to whatever the LLM has said. And the review report sets the review key in the state to whatever the LLM has written. With our agent tools set up, we can now create our agents. So we're going to be creating a slightly different kind of agent this time. We're going to be bringing in the function agent from core agent workflow. There are 2 types of agents that you can create when you're creating a multi-agent system. The function agent is a function calling agent. It is designed for more advanced LLMs that can call functions natively. They are more reliable at calling functions. But if you have an LLM that doesn't support function calling, you can always use React Agent. But because OpenAI definitely supports function calling, we are going to use the function agent. The parameters it takes this time are a little different than when we set up our agent earlier using functions or tools, because now there are multiple agents. So we have to give the agents a way to tell each other apart. So we have to give them a name. And we're going to give them a description because they're going to use this description to decide which agent they should hand off to. In a multi-agent system, the agents work together. They will perform tasks that they believe that they are good at. And if they believe they've run into a task that they're not good at, they will hand off control to another agent. So we've given this one a system prompt that says you are a research agent and what you should do. We've given it the web search tool and the record notes tool. And we've given it a hint. This is not a strict guideline saying that it can hand off to the right agent. This is optional. We don't have to. If we don't say what agents it can hand off to, it will figure it out on its own. But this can add a little bit more structure to your multi-agent system. So we have a function agent, a write agent here with the different prompts, and it can hand off to the review agent or the research agent. And we've got the review agent here, which can hand off to the research agent or the write agent. Now, to create our multi-agent system, we now call AgentWorkflow directly, and we give it the agents parameter, which is just an array of those agents that we just created. We have to set the root agent, which is what agent is in control when the workflow starts. And we can also set our initial state. This is the state variable. These are all the values of it when the research begins. As the workflow runs, it's going to spit out a series of events that let us know what's going on under the hood. We are going to set up our event handler to print out these events with some pretty printing so that we can see which agent is in control at any one time and what that agent is doing. we are calling AgentWorkflow.run with a user message telling it to write me a report on the history of the web. And we are going to look for each event. And if there's an agent name, we're going to say, print out the name of the agent. If it's an agent output event, we're going to output it. If it's a tool call result, we're going to output it. If it's a tool call, we're going to output it. And this is what that output looks like. You can see that because we said the research agent should start, that is the agent in control when it starts. It calls search the web several times. It records notes several times. And then it decides that it's going to hand off to the right agent because it has done the research. So now the right agent is in control, and the LLM will write the report using the values in the state as its research. And then it will use the write report tool to write the results to the state and hand off again, this time to the review agent. The review agent will say what it thinks of the report. In this case, it says, I approve the report as it stands. And we can see the final output by calling the state and getting the report content out of the state. As you can see, it has written us some nice markdown with a detailed history of the World Wide Web. We can also print out the review and see what the review agent thought of this report. So congratulations again. You have now built a multi-agent system using our high-level agent workflow construct. The next thing that we're going to do is we are going to drop down one level to workflows and build a more detailed, constrained system using the workflows construct. Why would you want to do that? A bunch of reasons. One is more fine-grained flow control. Workflows allow looping and branching, parallel calls, map-reduce behavior. It allows you to very precisely specify how data is going to move around your agent or your multi-agent system. You can control your inputs and outputs more. So instead of just accepting a string, you can accept anything. And instead of just outputting a string result, you can output anything, like imagine JSON. To plumb your agent into a larger piece of software, it would accept JSON as input and output JSON again. You can also do things like multimodality, query planning, reflection, a whole bunch of more advanced agentic behaviors not supported by agent workflow. So let's look at how that is done. You create a new workflow by creating a class that descends from workflow. All workflows are just regular Python classes. We're going to need some new imports to get that done. We're going to bring in a start event, a stop event, the workflow itself, and step is a decorator. Your workflow class should consist of a series of Python functions that are marked as steps with the step decorator. And that is how the workflow knows that it should be passing from one step to the next. Steps take type annotations. So in this case, I'm saying that it accepts an event, and that event should be of type start event. And I'm saying that it returns a type stop event. These are very important to how workflows work. The type annotations are how the workflow decides which step gets run. If an event gets emitted, then the step that accepts that kind of event will run automatically. That is why we've said that it should accept a start event, because a start event is emitted automatically when the workflow begins. And when you emit a stop event, the workflow halts automatically. So in this case, this is the simplest possible workflow. We've instantiated the workflow, which is called my workflow, and we've called workflow.run on it, just like we did with multi-agents and agent workflow. And we printed the result and we got hello world. All of this has been running in a notebook. Notebooks are async by default, so things like await work automatically. If you are running this in regular Python, you would need to do one extra step, which is you would need to create a main function and run it with async IO, and then have this main function be async so that your await constructs can work. In a notebook, you don't need to do this, and in fact, it won't work. So this is just when you are running real workflows in vanilla Python. One of the great features of workflows in LlamaIndex is that they come with a built-in visualizer, which allows you to see what your workflow looks like when you visualize it. So we're going to install LlamaIndex utils workflow now, and we're going to call draw all possible flows. What this does is this outputs an HTML file with a visualization of your workflow. In this case, we have the simplest possible workflow. It just has a start event going to my step, going to stop event, which is obviously not very useful. So let's create a multi-step workflow and see what that looks like. To create a multi-step workflow, we need to create some additional events, because if you remember that visualization I showed earlier, the way a workflow works is steps pass data to each other via events. So we're going to create a first event and a second event, and we're going to create a workflow that has 3 steps. Step 1 accepts a start event and emits a first event. Step 2 accepts that first event and emits a second event. Step 3 accepts the second event and emits a stop event. We run it just like we did before. We give it our input, and you can see that it starts the workflow first, second, and then it completes. If you run this through the visualizer, you get this. This is a chain. So you can see step 1 emitting its first event to step 2, second event to step 3, and then it stops. But while that's fun, obviously a completely linear flow is not very interesting or very powerful. So let's see what other things that we can do with our control flow. The first thing we're going to look at is looping. A key feature of workflows is their enablement of branching and looping logic, which is much simpler and more flexible than graph-based approaches. To enable looping, we're going to create a new loop event. Unlike start event and stop event, this is not a special event. You can use any event to loop. We are going to create another 3-step workflow, also called my workflow, but this time there are going to be some differences. Our step 1 is going to accept either a start event or a loop event. Our step 2 is going to emit either a second event or a loop event. And we're going to use some random math to decide which of those we emit. We've told it to choose between 0 and 1. If 0 happens, then it will say that something bad happened and it will emit a loop event. By emitting a loop event, it will send us back to step 1. If it gets a 1, it will emit a second event, and second event will send us to step 2. So the key thing to note here is that the order of this execution is based on the events. It's not based on the order of these steps appearing in the code. We run this workflow just like we run all of our workflows, await workflow.run, with the first input start the workflow. And this time around, we see that it started the workflow, the first step completed, then the bad thing happened. So it went back to step 1. Then the first step completed again, and a good thing happened. That meant the second step could complete, and then the workflow was done. We can visualize our looping workflow, and we can see the loop in action. So we see step 1 emits a first event going to step 2, which can either emit a loop event and go back, or it can emit a second event and go forward. Very closely related to looping is branching. You will often want your LLM to make a decision and then your workflow to act differently based on that decision. That's what branching is useful for. So here I've created a branch A1 and a branch A2 event, a branch B1 and a branch B2 event. And I've created a workflow with 5 steps. The start step uses our random math again to decide whether or not it should go to branch A or branch B. If it goes to branch A, it emits a branch A1 event, will emit an A2 event, and take us to step A2, which will emit a stop event. If it gets a 1, it will go to branch B. Branch B1 event will emit a branch B2 event, which will take us to step B2. It visualizes like this. You can see our 2 branches and our 2 chains attached to each branch. The final form of flow control that you can implement in workflows is concurrent execution. This allows you to do several things. It allows you to efficiently run long-running tasks in parallel. It allows you to split a complicated piece of work up into smaller pieces of work, and it allows you to perform MapReduce style tasks. To do this, we're going to be using the context object that we already encountered, and we're going to use a couple of new methods on the context object. In our first example, we're going to create a new step 2 event and a parallel workflow. Our start step in this case is going to call a new method on the context called sendEvent. Where did we get the context? We set it as our second parameter to our step, and the framework magic has again given us the context automatically. So We're calling send event here. Previously, we've been using return. We've been returning a single event from every step, but we don't have to do that. We can emit as many steps as we want. So what we're doing here is we are emitting 3 different events: query 1, query 2, and query 3. And each of them is a step 2 event, so they will trigger step 2. We've added a parameter to our step decorator here, saying the number of workers. This is how many times this step can run concurrently. We have given our step a random number of seconds to wait before it returns, but then it returns a stop event. When we run this new parallel flow with start the workflow, you'll see that it runs slow query 1, slow query 2, and then slow query 3. And then query 1 comes back. The first one to complete was query 1, and it emitted a stop event, and that stopped the whole workflow. It didn't wait for the other 2 queries to complete. That's sometimes useful, but sometimes you would want to get all of your events back. So let's see how that works. In this concurrent workflow, our start step is the same. It sends out query 1, query 2, query 3. Our step 2 is almost the same, except it emits a step 3 event. In step 3, we're calling a new method on the context called collect events. It accepts an event and a parameter that defines what events it should wait for. What it does is it collects events and it attaches them to the context, and it waits until it has received all of the events that it's been told to wait for before it returns anything. This step is going to trigger each time step 2 completes, but the first 2 times it runs, collect events will return none because it hasn't received 3 events yet. So we say if the result is none, we just say that we didn't get all of the events and we return nothing. But if the result is something, we print out that result. So let's look at concurrent flow. We run it. We say start the workflow. It runs query 1, query 2, query 3. And like I said, it says not all events received yet. It says that twice. And then on the third run, it has received all 3 events that it was expecting. And so it prints them out. Note that these events are returning in the order that they were collected. So not in the order that they were sent out. This is non-deterministic, so you need to have IDs on your events to make sure you know which one is which. So far, we've collected the same event 3 times, but what if you want different events to be fired off and collected? That's very easy to do. In this case, I've created a more complicated workflow that has a step A event, a step A complete, step B event, step B complete, step C event, step C complete. And our start method is going to emit 3 different types of events. It's still query 1, query 2, query 3, but this time it's a step A event, a step B event, and a step C event. These go each to their own step. You do something A-ish, something B-ish, something C-ish. Each one of them emits their appropriate complete event. And step 3, we have marked as being triggered by any of those 3 complete events. It says if it's received the event and what it is, and then we've called collect events. This time, instead of saying 3 of the same event, we've said collect a step C, a step A, and a step B event. As before, if collect events returns none, then we do nothing. If it returns something, then we print them out. When we run this, you'll see that it says that it's doing something A-ish, something B-ish, something C-ish, and it receives query 1, query 2, query 3. And your thing to note here is when it prints out the events are in the order that they were defined in collect events. So we said, give me step C, then step A, then step B. And here in the output, we have step C, then step A, then step B, even though they actually executed as A, then B, then C. This workflow has a pretty pleasing visualization. You can see the start step going to A, B, and C, each of which has their own little chain, and then they collect up at step 3 before they stop. We already saw that AgentWorkflow, which was what we were using to create agents earlier, emits a stream of events that we can handle and filter when we run the workflow. We can do the same thing when we are working with workflows directly. We just need to send those events explicitly. In this workflow, in step 1, we've created a progress event. And in step 1, we are creating and calling a new method on context called event to stream. And we're passing it a progress event saying that step 1 is happening. In step 2, we're using our LLM for the first time. And we're asking it to give us the first 50 words of Moby Dick. And we've asked it to do this asynchronously, giving us a stream of results, which gives us a generator. So for each chunk of response from that generator, we're going to write an event to our stream called a text event, which contains the text delta from the LLM. When that's done, we will return a second event saying that the second step completed, and go to step 3, where we will write one last progress event saying that step 3 is happening. We handle the output just the way that we do for any agent workflow. We call workflow.run, we get our handler, and we look for instances of our progress event or instances of our text event, and we print them out slightly differently. And we can call await handler to get the final result as well. This is the final output of the stop event. So you see the output here, step 1 is happening. Then it gives me the first 50 words of Moby Dick. Then it says step 3 is happening, and then it gives us the final result, which is that the workflow is complete. So congratulations yet again. You have now put together a workflow from scratch that does agentic things. Now that we've got these primitives down, we've understood how to do looping and branching and stuff like that, we're going to put all of those skills together and create our own deep research clone, which we're going to build now. To build the deep research clone, we're going to have 3 agents. We're going to have a question agent, which accepts a research topic and generates a bunch of questions. We're going to have an answer agent, which answers a specific question. So we're going to need to call it many times to answer each of the questions generated by the previous agent. And then we're going to have a report agent, which aggregates all those answers and generates a report from all of the answers. Just as when we were creating agents for agent workflow, we are going to use the function agent. Our question agent doesn't take any tools. It's just given a system prompt that says its job is to take its prompt and break it down into multiple questions. The function agent has the same search web tool that we've been using the whole time, and a prompt that tells it to search the web for answers to the questions that it has been given. And then the report agent is told that it is going to be given a set of answers and that its job is to combine them into a comprehensive report on the topic. So this workflow, we're going to need to handle several tasks. It's going to need to accept the topic and pass it to the question agent. It's going to need to take all of the answers from the question agent and split them up, firing off one answer agent for each question. Each of the answer agents is going to need to answer the question, and then we're going to need our report agent to accept all of those answers and generate a single report from them. So let's see what that looks like. We're going to have some events, a generate event, a question event, an answer event, and a progress event. And we're going to create with them a deep research workflow, as usual, descending from the workflow class. So it will accept our 3 agents, the question agent, the answer agent, and the report agent, and it will store them. And while we're at it, we're going to write an event to stream saying what we're doing. Then we're going to call generate event, which will trigger the generate question step. This is going to set our research topic into the context in case we need it later. And it's going to write an event to stream saying what's up, that it's doing a research topic. And now it's going to call the question agent, asking it to generate some questions on the topic, where the topic is the research topic passed in from the generate event, which was itself passed in from the start event. Now we're going to do some basic string manipulation, which is going to take the answers, which are going to be on one line each, and split them into an array of questions. We're going to remember how many questions there are, because that's how many questions we're going to have to wait for. And then for each of those questions, we're going to emit an event. We're going to emit a question event. So the question event triggers the answer question, receives one question at a time, and its LLM prompt is to search the web to get answers to that question. We write an event to stream with a progress event, and then we trigger an answer event that contains both the original question and the answer that it got. Now, in write report, we're going to call collect events. Collect events is going to wait for answer events, and it's going to wait for the number of total questions that we emitted earlier, we stored in the context. As usual, we're going to write events to stream saying what's going on. Either we are still collecting answers or we're ready to generate the report. Once we've got all of the answers, we're going to aggregate them into a single big string and put that into our prompt saying you are part of a deep research system. This is your topic. Here are all of your answers. Please generate a report. To get this to run, we call workflow.run and we pass in 4 things. We pass in our research topic and we pass in the 3 agents that we created earlier. Our handler is very simple. We're just looking for instances of the progress event and printing them out. And then we're going to await the handler and print out the final result as well, because that is going to be the report. The output here is very long. So you can see it starting research, you can see it collecting answers. This is the final step, but it hasn't received all of the answers it's waiting for yet. So it collects answers, it collects answers, it collects answers on the history of San Francisco. And then once it's received all of the answers, it generates the report. And here is this report, more markdown, a comprehensive history of San Francisco. So that's pretty cool. We've created a workflow that does deep research, but we can do better than one-shotting. The next thing we're going to do, the final thing we're going to do, is add reflections. One of the things that LLMs can do that's really amazing is they can judge their own work and decide whether or not it is good enough. So we're going to use looping to add reflection to our agent. It is going to judge the quality of the report that it's created. And if the quality is not up to snuff, it's going to generate some feedback and pass it back to itself to say, okay, generate some more questions and try a second time. So we have to do a few things different for that to work. In research, we'll have to store the research in the context because we might use it multiple times. We'll tell that it can be triggered by a rewrite event in addition to a write event so that we get our loop going. If it's a rewrite event, then we will add the review as feedback to the prompt because we'll be expecting a review from the review agent. The review will be changed to optionally emit that rewrite event. And we're also going to get the LLM to decide in the final step whether to say the review was bad or good. And if it's bad, it will emit the feedback that we're going to be passing around. So we need some new events for this. We need a feedback event and a review event. And we need a new agent, a review agent, whose job is to read the report and decide whether it was good enough. So we're also going to add a safety guard here, which is we're not going to let it do this more than 3 times, just in case it gets locked in a permanent loop of not liking its own research. So we'll count how many review cycles have happened. Our setup event is mostly the same apart from that. Generate questions is mostly the same, except it's going to be triggered by either a generate event or a feedback event. If it's a feedback event, it will detect that and it will add the feedback to the prompt in addition to the original prompt. And then it will run the question agent like it did before. We will count how many total questions we got, just like before, and then we'll fire off our questions as before. Our answer question step is exactly the same. Our collect events is exactly the same. This writes the report just like it did before, except now it emits a review event. The review event is going to be captured by our review step, and our review step will do one of 2 things. Either the LLM is going to admit the string acceptable, in which case it will emit a stop event with the report, or if it's not acceptable, it will assume that the string that it's got back from the LLM is the feedback, and so it will emit a feedback event with the original research topic plus our feedback. It's also going to count how many review cycles there were, and if we've done more than 3 cycles of review, it will also say that this report is good enough and output it. Running this is just the same as when we ran all of the other ones. We call workflow.run. We pass in our 4 agents now. We give it a research topic, the same research topic as before. We output progress events just like we did before, and we output our final results just as we did before. This time, we get even more output. So it starts the research, it collects answers, it keeps going until it has collected all the answers, and then it generates a report. But it didn't like the report the first time. You can see that it sent feedback, sending feedback, and here's the feedback. So it said it sent a list of questions that you could also ask to get deeper research. So it does that. It answers more questions. It generates another report, still doesn't like it, more feedback, and then it finally gets the right answer and it generates the report. An even more detailed, even more deeply researched report than before through the power of reflection. If we visualize what this looks like, you can see our loop. You can see we go from setup to generate questions to answer question. to write report to review, which can either send us back to generate questions or send us to our stop event. So one final congratulations. You have now gone all the way through this tutorial. You've started at building a simple agent using Agent Workflow to building a multi-agent system using Agent Workflow. Then you dropped down one level to workflows themselves. You built an agent using direct workflow calls, and then you rebuilt a deep research system using workflows and multiple agents. You've learned a whole lot. I hope this was interesting to you, and thanks for listening.